How are you guys doing? My name is Leon Jin. Today, I'm with my partner Andre Diaz to introduce our test approach. Like right now, let's give the mic to Andrew. Please go through the documents.
Hello, everyone. My name is Andre. So today we're going to be going through a test suite demonstration. I'm going to be going into our project of Visual Studio Code and executing some of these tests. I want to start off by explaining some of the tests that I will be going through. So first, we're going to look at some unit tests. These tests are serving the function of ensuring that our data objects, getters and setters are working properly. This data object, since we are using the Spring Boot framework, these data objects are going to be marked with entities as entities. And we will use these data objects along with the Spring Boot JPA to save the the fields associated with them as a tuple of our database for each table. So how we broke out the table structure for our database was 4 tables. There is a users table, a processes table, a CPU table, and a memory table. So I'm going to move over to Visual Studio Code so we can look at that. So over here is our table objects tests. So this is the unit tests for our 4 data tables. So up here at the top, since we are using Spring Boot, we're using their Spring Boot test library. This class has been marked or annotated with the Spring Boot test, which is essential for using Spring Boot to execute these tests for us when the project is built. I've then annotated each of these 4 methods with the @test annotation. The @test annotation marks this method for any time the project is built. It's going to execute this method to and ensure that the method passes. If the method fails, then the build will be considered a failure, and that indicates that there's an issue with the getter or setter of each one of these objects. So we have the memory test. We start off by grabbing the local date time now. This is used for setting the date time. We then set the other fields of memory, such as memory usage, speed, and memory available. Then we use the assert equals method to compare and ensure that when I call memory.getDateTime, it matches the current time, which was the time supplied to that memory object. So this is done to each of those fields. And as long as the object's getter returns what I used, returns the same value as these expected values that were used to for like the setter, then that checks out and ensures that our object is functioning properly. So we do this for the CPU, the processes, and the users table as well. So we just go through and test each one of these setters and each one of these getters. And as long as all this passes, we're in a happy state. So for the other aspect of the database testing, because this is what I just showed you for the unit test is pretty low level. That object in itself does not make its way to the database. Since we're using Spring Boot, there's a repository aspect of this. It's a repository object, and that repository object is what actually takes these 4 different table entity objects that I described and actually saves that inside of the database. The repository object is also what we will use to return information back or grab or query information from the database. And this will be accomplished using various aspects of the Spring Boot starter test dependency. The library is actually pretty fascinating. It has includes as like a part of it the JUnit, AssertJ, Makito, and other libraries that assist in testing Java applications. So the we've already discussed the table objects tests, which is where we are conducting the unit tests for those 4 data objects. What I will be showing you next is the database integration test. And this is testing how to ensure that once those objects have their values set using the set methods, that object is then saved properly inside of the database. The other aspect of that, which follows, is that I will then query the database with that date time, which should return the object that I'm looking for. And then I will check that object's data to ensure that it matches the object that I originally used to save that data. As long as those 2 match, then we know that it returned the correct object and that it is functioning properly. So I'm going to move over to Visual Studio Code just to so that we can see what that code looks like. So this is the database integration test. I start off by doing the Spring Boot annotations, like Spring Boot test for the class to ensure that this is run, as well as at test for every single method that I would like to be executed as a part of the test. So we can see here up at the top that it's kind of similar to the unit test in that I'm using the CPU objects set methods to store all of the data into the respective fields. This is where the CPU repository object that I was discussing, if we actually just peek on that object very briefly, we'll see that it is marked with an at repository annotation. That annotation marks it as a repository, which allows it to be used for creating the data tables. And not only just creating the data tables, but then storing the information inside of it and updating it and fetching pretty much your basic CRUD operations. So I call the CPU repository save method and pass it this CPU object, which has all of this data stored inside of it. And that CPU object is now saved as a part of the database. Now, to ensure that that actually was successful and worked properly, I then query the CPU repository using this function I created, find by date time, supplying it this CPU object's date time by using the get method. And since we passed all the unit tests, we know that this will work properly. So this should return, this saved CPU should have the same information that this CPU up here has. And that's when we begin our assert equals to compare one CPU's processor type with the other CPU's processor type. And we do this for every field for that object. And as long as everything passes, then this test is considered a success and we do not have any issues. Now, this pattern is repeated for the memory table or the memory database, rather, the processes data aspect of it, and the user data aspect of it, where we save test data into a object that represents the table. We then call the save method of the repository, and then we query that repository for that object based on a predefined condition or a field. And then we use assert equals to compare everything. And as long as everything passes, then that's good. So I'm going to go ahead and just run this very quickly. Once this finishes executing, we should be able to see that it says success, that all 9 tests were run. and we have 0 failures and no errors and 0 skipped. So this was very successful. So my project partner is going to take over now. Thank you so much.
For the API testing, we want to ensure the RESTful API performs as expected, and the RESTful API allow us to perform the CRUD operations using a post, get, put, and delete. Now right here, the tool I'm using is the Postman. It's a platform that allow us to easily do the API testing because like GUI friendly. It's easy to learn. It's not that hard to do that. So for the get request, basically we're gonna get all the metrics data. Like we're gonna get the users, CPUs, memory, and process informations. When you successfully run that send that request, you will get 200 OK status. For the post, it's basically is update. So you are gonna will request submit to an API will request body, and this request submit the JSON data, and the data is reflected in the response. After the expected response is 200 OK or 201 create a response code. For the delete request, we want to make sure that like we can delete data from the previous like object what we create in the post request. So what do we expect? 200 OK, 202 accepted, or 204 no content response code. So right here, let me show you the code real quick. So for the code, we're gonna use the CPU as an example. As you see right here, the CPU controller basically is to define the controller class, and it will take care of all the HTTP request. As you see right here, like we have the annotations right here: get mapping, post mapping, put mapping, and delete mapping. These are pretty important for doing the CRUD operation. I want to mention about like right here, I put a response status. Like right here is like HTTP status dot created. The reason why I put right here is like after you add some CPU information, for example, like if you add another object, I want the response code to be more specific. I want to return like 201. I want to return 201 code instead of 200. So this can help a lot to me. And for the CPU service, as you see right here, we insert some fake data right here. We insert some fake data, and like we can get the CPU by the ID. If we cannot find it, okay, then we're gonna throw an arrow, and we're gonna add the CPU, update CPU, delete CPU. Let's go back to the Postman real quick. So basically, the Postman is like it's allowed us to do the automated API testing instead of like manually. Manually is kind of too much like pain in the butt. So you definitely don't want to do that manually. And as you see right here, I'm gonna use the users as example. So you can see the overview right here. You can like send a request, we will respond, send a new body data, and then you can like do a bunch of things right here. But what I verify right here, just want you to know, this is the test, the JSON code for the testing. So first, I want to make sure that like, did I successfully send a request? If yes, then send me 200 code, 200 code. And right here, as you see, we have the two body. Like as you see, this is a body right here. For example, if I send a request, it's send the body back. This is what we and the pre-request script basically is show the expected result, what we expected. For the test, we are not only check the static code and not only check the body structure, also we want to check the body content. So that's why we say right here, okay, we're gonna compare with like the response body and like a response right here. We want to make sure like the content is like exactly same what we expect. So for the post users, exactly same things. We want to make sure the things this is what we add right here. Like this is the new user what we want to add, and this is the user the response body we expect, and you see right here, it's the same. And like you are pass the if it's like this is the test result what we expect. For example, if I just like put email, just for example, I'll put a integer number, just put a 1. If I send it, you'll see the test result won't be passed. And it will show specifically like what happened, then it's easy help you to debug, to check what happened, what's wrong. For the update, basically same things. And also delete, we only for the update, we expect like 200 201 and 204 code. So right here, you see, this is what we expect. Everything is like a pass. And we also can delete that. For delete, as you see right here, like delete the CPU, delete for all the deletes, basically we choose to do the like users right here. Sorry. Yes, the users right here, we choose like boolean. If it can be successfully delete, then it will return the true value. If it cannot be deleted or it's like there's no object you can delete, then it will return a false object. So for example, right here, I already delete that. If I send delete request again, boom, it's false. There's another thing I like to mention about, like it's about like Postman Runner. It's pretty powerful like a platform to do the API testing. Right here, you can see you can like run manually. You also can schedule runs or automate runs like will command line. Like right here for this demo, I'm gonna show you. For example, I'm gonna run 3 iterations. I just easily drag a CPU test or just whatever. I just drag a CPU test. I'm just run a test. Oh wow, it just shows like as you see right here, you can see what happened. Like oh, these two didn't pass, and there's like what happened, and you can see the view result right here. Just give more details. There's another good thing is like I the workspace you can share with like with your team members. They can also run with API testing VPI test API testing together. And also you can export all these like collections, and this collection will be exported to a JSON file. It can work with the Git action. It's also it's pretty good. And this is for the API testing. After that is for the dashboard unit testing. So the dashboard, we're still working on that. Right now we have an easy demo right here. It's just show the basic information. Nothing's clickable. But just want you to know, we in the future it will have two pages. First is a user login page. The second one is information page. And like the user login page basically is promotes users to insert to log in their account for authorized access. The information page is basically to displaying all metrics data what we collect from the computer of the running computer. And doing this test, we are manually test all the widgets and like make everything is like clickable and provide the correct feedback. So thank you. That's all for the testing.